Good morning and welcome to part 2 of our webinar today. This part of the webinar we will be going over some advanced functionality with the PLC I/O utility and also going over how to annotate wire information to your footprints. So first we're going to start off with some advanced functionality of the PLC I/O utility. This drawing may look familiar from part 1 of our webinar, where we created a drawing using a spreadsheet. This is the modified spreadsheet here that we'll be reviewing next. So again, we're going to use the PLC I/O utility to create some drawings. I'm going to start off with a blank drawing here and go through and add a few things to my spreadsheet to annotate some additional information, create links between parent and child components. You can also add spacers, breaks, and additional drawings to your drawing set here, and we'll start kind of going over some of that. So you can see here I've still got this spreadsheet up. We have the codes for the PLCs. I've inserted an additional spacer here. I could also insert a break here instead, where it would actually break these this PLC into two pieces. Some of the things that are supported within the default PLC I/O utility are adding jumpers between different lines. The way that you would do that is you would actually add in text to the block location for the inline device, and what that does is it actually creates a jumper between the two different lines. So right here I'm going to have a jumper between my 5th and 6th inline device, or 5th and 6th addresses here, and I am going to use the vertical character here, which is found right above your enter key. If you hold shift down, you'll get a vertical character here. And what that tells it to do is actually to put a wire in at that location. Following that, you'll have a series of W's and X's that tell AutoCAD Electrical how to trim or keep the wires there. So what this is showing here is that within my ladder, where that wire is going to be drawn, so as an inline device here, it's going to be drawn between these two locations. And what it's going to do is it'll actually draw a wire in here, and the W's and X's will trim or keep the wires. So a W here, it starts off with, it goes from top to bottom from left to right. So it would be W, W, and then an X would trim this wire, and then a W would keep this wire. So I'm going to keep this on either side of the top of the wire, and then I'm going to trim to the left and keep to the right. And that's what this is showing here. If I wanted to reverse that and trim the wire down to the bottom right, I would switch the order of those, where it would be W, 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 X. If you leave all of the, you can have all W's and just leave it as a vertical character, and then it will just leave all of the wires. It won't trim any of them off. So that's how you can add jumpers between different lines within your ladder. Also, you can add additional what I would call an inline circuit into your spreadsheet here. What this does is it allows you to W block a circuit. And if you're not familiar with W blocking the circuit, what you would do is actually draw up a circuit within a blank drawing, and you would create what I would call a subcircuit that you would put into your spreadsheet. So in this example here, I've placed a fuse and a child fuse underneath that. Link that back to the parent. And then we're going to draw in some wires. And I have toggled my snaps off because they were not quite lining up with the fuses that I wanted. And then I type X to see my wire connections. Now, because I want to create a bend in the wire, I'm going to type C, enter, to create a bend in my wire to go down to the child. And then I'm going to repeat that. So X to show my wire connections, C to continue, to create a bend in my wire, and there I've got a subcircuit. Next I'm going to go to the Insert tab again to write a block. Pick a base point. I'm going to create my base point wherever I want this circuit to be inserted. So I'm going to toggle those snaps back on here. Snap to the top corner. Select my objects. What this does is it actually creates a new drawing, but this tells AutoCAD Electrical that this drawing is actually a circuit. I want to go to my favorites here, and I will put that down in here. So now I've blocked this circuit and I can use that in my PLC I/O utility in the spreadsheet. So I would just type in that circuit name preceded by an asterisk. The asterisk lets AutoCAD Electrical know that that should be a circuit, and it will treat the wires, all the lines on that as wires and all of the components as smart AutoCAD Electrical components. The other thing that I mentioned is you can actually piggyback attributes on in addition to the standard attributes here as description, tag, and location. The only place that you cannot piggyback attributes is in the block column. That does need to be just the block name or the circuit name in that column. So for this fuse, because I've got two inline fuses that I'd like to use here, I'm going to tag the first fuse as FU1, and then the description will be blower. In addition to that, I'm going to add some rating information. You can piggyback any attribute onto this column or any of the other three columns I mentioned, the location, tag, or description, as long as those attributes are found within the block definition. So because I'm working with a fuse, it's going to have a rating 1 value, and I'm just going to add a semicolon here, and what that does is it allows AutoCAD Electrical to recognize that this is going to be an additional attribute piggybacked on, and then I'm going to define the attribute I would like to annotate, and then an equal sign, and then followed by the value of that attribute. So here, anytime you insert a circuit, you can only annotate the first item in that circuit. So I can only annotate that very first fuse. The other fuse will still come in, but I will have to annotate that after I've already created my drawings. The next thing that we'll kind of take a look at here, you can see I've got another rating value here for this pressure switch here, is how to tie parents and children together within the PLC I/O utility. So if we go back over to this side a little bit here, we can see here I have a control relay here, and the tag value is 645CR. Now on the previous couple lines here, I would like to insert a contact for that control relay. So I'm going to piggyback the attribute tag2 and give that the same value as the parent. Because parents and children are tied together by their tag name, what I'm going to do is actually have that tag name predefined to that contact for that relay. Again, I'm just going to put in the block name for that contact that I'd like to put in. That I know that is a horizontal relay child because it's a 2, and then 1 because it's a normally open contact. So tag2 equals 645CR. I do need to prefix that with the semicolon, and that lets it know that this is a piggybacked attribute. So there's going to be no value for the D1 tag 1 because the tag 1 information does not apply to this child component. Children don't have a tag 1 attribute value, but they do have a tag 2. After I've entered that information in here, I'm going to save that. You do need to save that as a 97 to 2003 Excel file. If you save it as a newer version, AutoCAD Electrical will not recognize that file. And then I can go back into my PLC-A drawing here and pull that information in from the Import Export Data tab, PLC-IO Utility. I'm going to use the spreadsheet I've just modified here, and I'm going to go out and browse to that spreadsheet setup file, that .wdi file that I created before. I'm going to use the active drawing here, and I'm going to add these drawings to the active project. Start. For some reason, this didn't pull in the one I was looking for here. Let's try that again. Seems to not be reading in my correct spreadsheet here. Make sure I'm picking the right one. Advanced XLS. There we go. So you can see here I have added some inline devices here. My spreadsheet is pulling in my cable color blocks that I've specified here, and then that jumper is showing up with the WWXW, so it kept this wire to the left and to the right to the top, trimmed the wire to the bottom left, and kept the wire to the bottom right. And that's between the 5th and 6th addresses here. So between the 5th and 6th addresses is where it created that jumper wire. My subcircuit here is shown right here as the inline device on my address number 8. And you can see it annotated just that very first fuse with the information that I specified. And you can see that rating value also was written out to the fuse here. This fuse has been tagged back, but does not have any description information to it. You can see this contact that I specified here to be related back to my relay here. That information has been annotated. If I go and edit the component here, it's tied back. But if I go back and look at the control relay here, it's not showing up as a normally open or normally closed contact. That's because the child was written in before the parent. So if I want to update that information, I would just go into the schematic, and I can verify that these are connected. If I use the surfer, it will pull up and show that the parent is indeed in this drawing. So what I'm going to do is actually go through and update that within my schematic panel here. And there is a button here to update the component cross-references. So I'm going to go here, save my drawing, and I'm going to go up and update this. So the reason this is showing up with so many is because I have so many drawings here that ended up not relating back. Close all of these. There we go. Now if I go back and update these component cross-references, that should clean that up. So I can do this for my project, active drawing, or active drawing pick. If I do it for my entire project, that should clean up this drawing. So once you've inserted those parent-child relationships, you just want to go through and update those contacts, those component cross-references. But that does allow you a lot more flexibility within the PLC I/O utility, where you can add jumpers, inline circuits, and also additional contacts and maintain those parent-child relationships. The next thing that we're going to take a look at is the footprint information. AutoCAD Electrical, by default, when you insert a footprint, does allow you to add wire annotation information to that. And the way that you can do that is when you've created a schematic with some components here, added your wire information to that, you insert your panel components, and if you select just the wire annotation information, I'm just going to select one of these, this allows you to insert wire information or terminal information to that panel footprint. But by default, this is going to come in at the 0, 0 point of wherever that panel has been defined. So for example, on this push button here, the center of the push button is where that M-text is being written out to. Because this footprint does not have the appropriate attributes on it for the wire annotation information and the pin list information, then that's written out as an M-text added to the 0, 0 point. What we're going to take a look at is how to actually define that within your footprint so that the information comes in more like this. So for example, for this relay here, I have the pins coming in and then also the wire information and where those are being written out to. So for the same control here, control relay CR1, I have the M-text coming in here at the 0, 0 point of that footprint. So let's take a look at this footprint here that I've defined with having the pin list information already part of it. What you're going to do is use the symbol builder to actually modify this symbol. And because it's in my drawing, it should come up within the list here. So I'm going to go find that particular footprint, and it'll come up with a PNG image because it's already been defined. And then I'm going to make sure that I select the panel footprint as my attribute template. What that does is it defines the attribute list for a panel footprint as opposed to a parent or a child or a terminal. It's going to give me a list of attributes that are required as part of a panel footprint. Select OK here, and then that will pull up this symbol along with all of the attributes that have already been defined on this. So you can see here I have a P tag 1, so that's going to pull in the tag information from the corresponding schematic component. So my P tag 1 is up here. I have my item information, description, manufacturer catalog. These are all of the attributes that AutoCAD Electrical is going to look for that panel footprint. You can see here now I have wire number information and terminal information. These are the attributes that AutoCAD Electrical is going to look for when it's looking to annotate that wire information out to the panel footprint. So as I add information, as I add contacts to correspond with these terminals within my schematic, and then I go back into my panel footprint, it will actually annotate that information instead of at the 0, 0 point of this panel footprint. We'll actually annotate that to these attributes themselves. This information will only be annotated if AutoCAD Electrical also finds a pin list within the catalog browser. The other thing that I've done in this panel footprint is I've added a WX-ref. What that does is if there's any additional information that AutoCAD Electrical does not find the particular terminal or wire information, if that's not been defined in here, for example, if I have a terminal 9 and 10, that will be annotated down here to this WX reference. So that would be if I add additional terminals to this particular control relay, then that additional auxiliary contacts information would be added down to this WX ref. So since I've defined the terminals that I'd like to see within this contact relay, I am just going to close this block editor. One way that you can add additional attributes here, if I needed to add a terminal 9 and a terminal 10, is I can add attribute within the block editor environment. That's just a little button right down here. I'm going to add the tag information, so I would say terminal 9. I'm going to leave the value blank. This is where I can either set the justification, this style of text that I'd like to see, the height here, I can change that, and then I can insert this. That allows me to add additional attributes to this particular symbol. After I've finished adding all of those, I'm going to close my block editor. Because this is a control relay, I've selected that from my family code here for my block name. And then I have unique identifiers and symbol names for this particular block. Unlike schematic symbols, footprint symbols do not need to follow a specific naming convention. So here I just have kind of the part number, and then also with an underscore wire anno, that lets me know that this particular symbol has wire annotation information as part of the block. I'm going to save this out into my file path here. Right now it's writing out to my NFPA directory. Also, the image information here will be written out to my images folder found in my user support. And then it's going to ask if I want to insert that symbol. Because this symbol already exists, it's not going to show me the updated symbol. If I did want to show that updated symbol, I would need to delete the footprint, erase the annotation information, and do a purge on this block so that I don't end up with residual information from the previous version. Just to show you what the difference is between these two different symbols here, I'm going to erase both of these. Delete this footprint as well. And then I'm going to go through and insert this. So from the schematic list here for my project, I'm going to insert the default footprint for that control relay. And you can see here this is just a basic rectangle here and the wire annotation information. If I pick that particular symbol here, what I'm going to show here is the terminal wire information, and I'll pick that symbol. It just inserts this mtext here, which is just mtext information that is perfectly editable. You can see here it pulls in the different contacts and then also the tag information where those are going to. Now I would like to insert the specific wire annotation footprint that I created. So I'm going to browse out to my footprint and I am going to grab that. From my library. So you can see here it has the same default insert point, and I'm actually going to replicate this and insert another version of that same control relay. It's going to yell at me and tell me that it already exists, but I'm going to do it for the, so you can see the two different footprints side by side here. Pushing enter here, you can see how that wire information here is actually written out on either side and showing the two different pins for that contact. If I go back into my schematic and add additional contacts in here, then I can update that information in my control relay in the footprint as well. So as I go and add additional contacts in here, and tie those back to my relay, now I can go back and you'll see that, additional information show up here. You can see how much neater this version is compared with just adding the wire annotation information and how much more meaningful this information is. When you are inserting the first version of the symbol here from the schematic list, you can see here you get some different options in the drop-down. I'm using just the footprint tables. What you can do is actually set up something called a wiring diagram table, and what that does is it maps actually a different footprint to that same part number within the manufacturer and catalog data. And what I would do is you can have a footprint table, which is just this basic rectangle here, which is the default footprint that comes with AutoCAD Electrical. But you can actually create an additional table here that uses the wiring diagram table, where you can put a separate footprint here that has the wiring information set up within the footprint to annotate it much more neatly. And the last choice that you can have is use the wiring diagram table and then second of the footprint table, so that if you don't have a footprint that has the wiring annotation attributes already created as part of it, that it will then use just the default standard symbol that came with AutoCAD Electrical. Like I said, you do have to have a pin list set up within the catalog browser in order for it to pull that information in. That information is being populated from the catalog browser to your schematic symbol. So if I can get this to undock here. So that pin list information is actually coming from here. That's where it's pulling the information in for your panel footprint. So if this information does not exist in your catalog browser, then it won't be able to annotate that information to these attributes here within your footprint. Does anyone have any questions? Are there any questions? Well, thank you very much for your time this morning, and I hope you found these tips and tricks useful.